Okay guys, so welcome back again to another video. So in this video let's talk about another type of alkylation, but in this case we are using DMPP, right? So you may heard of this molecule. This is not common as SAM, but this is again a particular very good molecule, very good reagent when it comes to alkylation, especially O-Alkylation. Okay, so what is DMPP? DMPP. So basically the molecule is dimethyl allyl diphosphate. Here I have mentioned it. So it's like this. Here we have the allyl part and here we have dimethyl part. Okay, so now for the particular O-Alkylation there are two pathways, right? Two mechanisms, SN1 and SN2. I hope you know what the SN1 mechanism and SN2 mechanism means. So first let me go through the SN2 mechanism. So now you must be able to tell how many steps they are contained with this SN2 mechanism. I told you this 2 doesn't mean the number of steps, right? This 2 means the order. For your particular reaction, this is the order. So in order to order become 2, which means the both of these reagents must be present in the predetermining step. Okay, so just in the mechanism part, right? You do not have to know about these, right? This is the order, how you can predict the mechanism by just looking at one. You don't need to have the skill for that, for this particular course. But for organic reactions, for organic chemistry and other stuff, I hope you know about these mechanisms and how to predict these things. Okay, now let's take water molecule, right? Let's take water molecule, and here we have our DMPP, which is PPO, like this. Okay, now what happens is this phosphate part, right? This phosphate part is a very good leaving group. This is a very good leaving group. So here we have a electron pair on our oxygen atom from our H2O molecule. This will go and attack to our this particular carbon. Why? Because this is a very good leaving group. So this is particularly a delta minus and this is particularly a delta plus. So this carbon is less electrodensitive. So basically this carbon has electrophile properties. So which this nucleophile, this electron pair can easily go and attack to this particular carbon. So with this attack, this bond will be broken. Okay, so now we will have our PPO is gone. Now we have here O, H. So I will remove this. Okay, this is our molecule, and oxygen has a positive charge. Okay, now what happens is normally in our biological systems there are enzymes. Like you need to know this particular point very well. Now when you are writing a mechanism in biological systems, right? You know, in order to remove this hydrogen you need a base, right? So but you cannot add OH minus, sodium hydroxide. You cannot use this kind of base because these are biological systems. So in a particular biological system there should be enzymes, right? Not particular like this KOH. These are not the bases in biological systems. So if you need to remove a hydrogen, right? If you need to remove a hydrogen, always remember you need to present a base in your mechanism. So now what happens, your base can attack to this particular hydrogen, so oxygen can have its electron. So now here we have oxygen, here we have our mechanism. This is oxygen alkylation by DMPP. So this is SN2 mechanism, right? So there is also the SN1 mechanism. Let me go through it also. So now you know what the SN1 mechanism means, right? SN1 mechanism means the first order reaction. So in the first step the leaving group will be left, right? This will left on its own. Now this will removed as its own. So now we have this. Okay, now this is very important, like this has structures right here. You can put this double bond over here, so you can obtain like this, which is more stable. This is more stable compared to this one, right? So this is more stable. So now these are two structures, right? These are two structures. Now you can use your oxygen for the alkylation. Now this will attack for here, and you will get the same thing over here, right? The same thing over here. OH. The other product can also be obtained, right? I mean, the OH can be attached to this place also, but you know, when it comes to SN1 mechanism, these are the two structures which are possible. So most probably it will go and attack here. But always remember, these are not the normal of, like, these are not the regular organic reactions. These are biosynthetic reactions, right? So there are particular enzymes, there are particular proteins which determines the pathway of your reaction. So if your particular pathway needs to go with the OH addition to here, then there are particular enzymes which tend this OH to attack for here, right? So it's completely fine if you draw it with here too, but for this case I will draw it like this. I hope you got the idea. Like, I need to understand this mechanisms, right? So when we are talking about more complex molecules, then the situation, like the environmental conditions, will allow us to predict like the where this OH go and attack. So there will be no problems at that particular case. But in this case, you need to understand the mechanism. That's all that matters for now. So I hope you got the idea for this mechanism. So these are very important. So in next video, we are going to talk about more alkylation reactions, especially in electrophilic additions.